This is the chapter 1.3, and today we are going to talk about nullability. So let's switch to the Kotlin playground and write some code. So here is our Kotlin playground, and last time we learned how to create a variable. We learned some keywords. So first keyword was val, and then comes the name of the variable, and we can equalize it to some number. So we created a variable type int. And other way to create a variable was to use keyword var. So let's call it another number, and let's equalize it to 20. So probably you already remember that the difference between those keywords is that you can basically reinitialize var variable. So this another number variable is reinitializable, and you can basically initialize it to some other number. For val it doesn't work. For val it's a final variable, and it can be initialized only once. So according to this fact, we know two types of variables. First one is final, this number variable, and we can write the comment. You know already what comment is, and we call it this is a final variable, or non-changeable. Next one is this is non-final variable, which means it could be changed. Another important differentiation between variables is either variable is nullable or non-nullable. So those variables are non-nullable by default. But if we want to create nullable variable, we need to use keyword var, and let's create nullable variable. For nullable variables, we would need to use type, and we specify types the same as we did for non-nullable variables, but here we need to put this question mark, which means that this variable is nullable, and we can equalize it to null. Null is fundamental concept in programming, which indicates a nothing. Now it's time to jump back to the playground. As we already discussed before, here we create a variable. But this is a bit generic term. Under the hood, a process is a little bit more complicated. And now I will try to explain it as easy as possible. But don't be sad if you will not understand something. As soon as you will get more experience in programming, everything here will become more understandable. So let's jump into it. In programming, there is such thing called memory. To simplify this term, it's a storage for your variables. When you create and initialize a variable, you reserve some memory area and store there your value, which is 15 in our case. Name here, which is a number, is a reference which leads to this memory area. Using the reference, you get a value, which is 15. According to this concept, what means this line? So this line creates a reference, which is nullable variable, which has no value, or this reference leads to nothing, to null. Let's check some real-world example. Imagine memory as a wardrobe, which contains some t-shirts. Here is the picture and some pseudocode, which is not going to be compiled, but anyway. Here we create the references to some t-shirts. So this is orange t-shirt reference. This comment, which is some code, means that we do some initialization, or we put our t-shirts into the wardrobe. Orange t-shirt is just a reference, it's not t-shirt itself. And we want to take the t-shirts from the wardrobe and execute some function, which is where. So we take the orange t-shirt, which exists in the wardrobe, and execute where function. The same for a yellow t-shirt, the same for a white t-shirt. But what about this black t-shirt? There is no black t-shirt in the wardrobe. And what is going to happen when you try to execute where function on the t-shirt, which is not exist? So there is only reference, no t-shirt. Let's find out. Coming back to variables which we created. So as we discussed before, we created a nullable variable type int, which is already equal to null. So this is our black t-shirt. Let's even rename it black t-shirt. It doesn't exist according to this null concept. I'm pretty sure that there is no where function for int type, but there could be some other functions. Let's call, for instance, function plus and some random number. So now we are trying to execute function plus for the variable which does not exist. Let's run our code. And as you can see, it's not compiling. It's written only safe or non-null asserted operators are allowed on the nullable receiver of type int. What does it mean? This means that Kotlin is so cool. So in Java before, it was a big problem that people or programmers, they were executing functions on null objects or variables, and they receive lots of errors. So the program could crash, which is obviously bad. But Kotlin, it does not allow you to compile this code even. So Kotlin is smart enough, and it basically alert you that this code doesn't make any sense. You cannot execute any function on the null object or variable. But there are some ways to not care about this assertion, and let's think that we are smarter than Kotlin compiler, and we can use 2 exclamation marks, which means that please compile it anyway. I'm sure I need it, and let's see what's gonna happen. So when you press run, the program is crashing. So you receive an exception, and it's written, this is null pointer exception, one of the most common exceptions in Java language. But in Kotlin is null safety language, which means that you cannot call the function on the null object or variable by default. So you feel safer here. There is also another operator, which is this question mark. What does it mean? It means that this function will be not executed if the object or variable is null. So this code is running, everything is okay, but this function will be not executed. So these are the great features of Kotlin language, which we'll use in future. Now you can ask, why do we need this null concept and why do we need nullable variables? Because obviously you would need to deal with null variables, and this is something we can't avoid. Android API or any other API which was written before in Java language or written by other developers, they can return you null, and you have to deal with it. You have to check if this variable is null or not. So there are lots of use cases when you would need this null variables. When you write your own code, I would recommend to keep it as less null as possible. So this is some sort of good architecture, but obviously this is also not really possible. So this is the reality. We would need to deal with nulls. I hope this lesson was understandable for you. So we didn't do any tasks, and I hope you understand null concept more. So please subscribe, comment, and share my lessons if you like them, and see you in the next lesson.